In this lesson, we'll cover the features and valuation of stock, common and preferred. Common stock represents ownership, is an equity position. In finance, we assume shareholders are active owners. Stockholders elect the board of directors who hire top management, who in turn hire down the ladder. So management is acting as agents for the owners, and as such, their goal should be to maximize shareholder wealth, meaning maximize the stock price. Common stock can, but is not required to pay dividends. They're not a liability of the firm as interest is on bonds. Each quarter, the board of directors meets and votes whether or not to pay a dividend and how much to pay. Dividends are not tax deductible to the firm, and they're ordinary income to stockholders. If a corporation owns a non-controlling interest in another firm, then a percentage of dividends received from that ownership are tax exempt. Thus, many firms own preferred stock in other firms. Remember this chart from Chapter 1? Outside investors, corporate insiders, and analysts have different information and use a variety of approaches to estimate a stock's intrinsic value. In equilibrium, we assume that a stock's price equals its intrinsic value. Outsiders estimate intrinsic value to help determine which stocks are attractive to buy or sell. Stocks with a price below its intrinsic value are undervalued. Those with prices above their intrinsic value are overvalued. These are the three techniques to value common stock that we'll cover in this lesson: discounted dividend model, corporate valuation model, models based on market multiples. We started our valuation of capital assets with bonds in Chapter 7, since bonds are much easier to value than stock. Recall that the value of a financial asset is the present value of its future expected cash flows, discounted at an appropriate rate. With a bond, at the time it's issued, we know exactly what each interest payment will be and when it will be paid. We know exactly how long the bond will be outstanding and exactly what we'll receive at maturity. Contrast that with common stock, which has an infinite life. We don't know when we'll sell it nor what we'll sell it for. We don't know if it will pay dividends or how much they'll be. Definitely a bigger challenge. So technically, the value of a share of stock is the present value of all its future dividends, to infinity. The fact that common stock has an infinite life means there is no closed-form solution to the valuation model. So we have to make some simplifying assumptions to come to a valuation formula. If we assume that a firm's dividend grows at a constant rate forever, using a Taylor expansion and a lot of math, the infinite valuation model can converge to the constant growth model. This is called the constant dividend growth model or the Gordon growth model. Note that D0 is the dividend just paid, so it's known, it's history. RS is the required return on the stock, and G is the constant growth rate. Be careful as to whether a problem gives you D0, the dividend just paid, or D1, the next expected dividend. Let's look at each component of the equation. D0 is the dividend just paid. D1 is the next expected dividend. By definition, it's equal to D0 times 1 plus G. G is the constant growth rate. RS is the required return on the stock. So where do we get this? Cap M, Chapter 8. If we're given a risk-free rate of 3%, a return on the market of 8%, and a beta of 1.2, we can find the required return on this stock, 9%. So what happens if the growth rate is larger than the required return? The formula returns a negative stock price, which is not feasible. So the constant growth model requires that the required return is greater than the constant growth rate. The dividend is expected to grow at a constant rate forever. With D0 equal to $2, a 4% growth rate, and our required return of 9%, we can set up our example on a timeline. D1 is equal to D0 times 1 plus G. D2 is equal to D1 times 1 plus G, etc. So D1 is equal to $2 times 1.04, 2.08. D2 is equal to $2.08 times 1.04, 2.1632, and so on. Taking this step by step, first calculate each expected dividend. If D0 equals $2, then we have a constant growth rate of 4%. Then you can see our dividends calculated right there. Discounting each expected cash flow back to time zero. Note that the exponent of each denominator in your calculator is the period in which the cash flow occurs. So D1 is that discounted back to time zero, $2.08 divided by 1.09. D2 is 2.1632 divided by 1.09 squared, etc. Using the constant growth model, we only need D1, G, and RS to find the price at time zero, $41.60. Let's step back and look at our constant growth formula, the one on top. We're usually solving for the price today, P0. But given D0 and a constant G, we can find the price at any time in the future. Suppose we want to find the expected price of our stock 1 year from now. Two ways to find it. Solve for D2, which we've already done, 2.1632, and divide by R minus G, 43.26. Or, if the dividend is growing at a constant rate G, then the stock price is also growing at the same rate. The stock price at time 1 is the price at time 0 times 1 plus G. Same answer, 43.26. An asset can only generate return in two ways, cash or price appreciation. For our stock with a 9% return, the dividend yield is the cash return. DY is equal to D1 divided by P0, 5%. The capital gains yield is the change in price. For a constant growth stock, it's the growth rate. So, total return is the sum of those two. What if the growth rate's 0? Then the G drops out of the numerator and denominator, and we're left with the constant dividend divided by required return, which is the formula for a preferred stock. As long as dividend growth can be reasonably assumed to be constant forever, finding the value of a share of stock is fairly easy. But what if the stock is growing at a supernormal rate for a few years before settling into a stable growth pattern? We obviously can't use the constant growth model, at least not for the non-normal years, but at some point the growth does become constant. Let's assume our stock is going to grow at 30% for year 1, 20% for the following year, 10% in year 3, and then stabilize at 4% forever. Required return is still 9%. The timeline chart lays out the solution technique. Put the growth rates and required return on the timeline. Calculate the non-constant dividends and the first constant dividend, D4. Use the first constant dividend to find the horizon value, or the stock price, at the end of the non-constant growth period. The horizon value, HV, is the first constant growth dividend divided by R minus G. Note, the horizon value here is the price at time 3, which is equal to D4 divided by R minus G, and it's discounted back 3 years. D4 is not used for anything else. Discount each non-constant dividend and the horizon value back to time 0. Sum the discounted values to find the stock price. This method is followed step by step in the video tutorial posted with this lesson. Once you have the timeline set up correctly, you can use the cash flow worksheet in your calculator to find the stock price. Remember how to handle the horizon value of the stock at the end of the non-constant growth period. In this example, cash flow 3 is equal to dividend 3 plus the value of the stock at time 3, P3. CF0 will always be 0 since the current dividend, D0, is history, and it's irrelevant in finding the current stock price. So what does dividend yield and capital gains yield look like for a non-constant growth stock? They're calculated in the same way, but are simply not constant. For the first year, dy is d1 over p0, 4.14%. So capital gains yield is the 9% minus 4.14, 4.86. Once the dividend begins to grow at a constant rate, dy and capital gains yield stabilize. Dividend yield will be 5%. Capital gains will be the constant growth rate, 4%. In this example, the dividend doesn't grow for 3 years, and then it begins growing at a constant 4%. The solution technique is exactly the same. As with our other non-constant growth example, dividend yield and capital gains yield are found in the same way. The yields add to your 9%, but the capital gains yield does not equal the growth rate. Once the growth stabilizes, capital gains yield is the growth rate again, Dividend yield is the required return minus capital gains yield. This video tutorial walks through a non-constant growth stock example step by step, including using the TI Business Analyst 2 cash flow worksheet to find the stock value. Note that while the CF worksheet can ultimately be used, you must work out the timeline to find the values to use in the worksheet. Take the time to watch this video and make sure you understand and can find the current price of a non-constant growth stock. If the stock has negative growth rate, does it still have value? Well, yeah, it does. Same example, but now the constant growth rate is a negative %. Be careful with the negative, especially in the denominator of the formula. Again, capital gains yield, it's found in the same way. G is negative, but it's still constant, which means dividend yield makes up for it by being 13%, and is sufficiently large to offset the negative capital gains. Our second valuation technique is called the corporate valuation model, or the free cash flow model, which values the entire firm, not one share of stock. Remember from our early chapters reviewing accounting, free cash flow is the after-tax operating income minus net capital investment. The formula is shown on the slide. Using the free cash flow model, we don't find a share price, we find the value of the firm in total. To find the value of a share of stock, we need to find the market value of the firm's operations, add the market value of any non-operating assets, subtract the market value of debt and preferred, and divide the resulting value of common equity by the number of shares outstanding. The free cash flow model is often preferred to the dividend model since it can be applied to firms that do not pay a dividend or to ones whose dividend is hard to forecast. The model does assume that at some point free cash flow will stabilize at a constant growth rate. So it can also be used for firms whose free cash flow grows at a constant or a non-constant rate. Where we found the value of a share of stock at the end of the non-constant period, in the free cash flow model we'll find the horizon value or the value of the firm at the end of the non-constant growth. Recall our basic valuation model for a share of stock and how, by assuming a constant growth rate, we could simplify it to the constant dividend growth model. We can do the same with the free cash flow model. Note that when using free cash flow, we're discounting by the firm's weighted average cost of capital, which we don't cover till Chapter 10. But using the same assumption of constant growth, we simplify to a free cash flow version of the constant growth model. Let's walk through an example. Free cash flow for the past year, FCF sub 0, $100 million. Pay attention here, free cash flow 0 or free cash flow 1. Same caveat as with D0, D1. Constant growth rate, 8%. Cost of capital, 12%. Market value of the firm's debt and preferred, $500 million. The firm has 50 million shares outstanding. Using the free cash flow growth formula, we find the value of the firm to be $2,700 million. Subtracting debt and preferred, the value of common equity, $2,200. Divide by number of common shares, we get a share price of $44. With free cash flow, non-constant growth is frequently not a non-constant percentage, but rather estimates of free cash flow dollars. Other than being presented with dollars, the technique is the same as with a non-constant growth stock. Here, we find the value of the firm, $877.50. If the firm has $40 million in debt and preferred, $5 million in non-operating assets, and 10 million shares, the value of common equity, $877.50, plus 5 minus 40, $842.50. Divide by your 10 million shares, share value, $84.25. Our third method is the firm multiples method. This one is more a benchmark, back-of-the-envelope technique. Price earnings is the most commonly used multiple, with price to cash flow and price to sales sometimes used when firms don't have positive earnings. This method involves finding comparable firms and using their average PE ratio against the study firm's earnings to estimate a share price. Technique is subject to serious estimation error depending on how well the comparables are chosen. We don't see preferred stock traded much anymore, but it is out there. Preferred is sort of a hybrid security. It's valued as a perpetuity since its dividend is constant. The dividend is fixed, more like bond interest. A preferred dividend can be skipped, but the firm cannot pay any common stock dividends until the preferred dividends are caught up, called a cumulative provision. Preferred equity has an infinite life like common stock. Note that the formula for valuing a perpetuity is just the constant growth equation with g equals 0. In our example, a preferred stock pays $5 annual dividend and is currently selling for $100. In this case, we turn the formula around to solve for the required return, 5%. This ends our coverage of stock and its valuation techniques.